everyone, let us quickly look at this simple AC circuit calculation question. It says, calculate the following in the circuit shown below. You can see the circuit and the components parameters that are in the circuit. We're asked to calculate the reactance of the circuit, the impedance of the circuit, the voltage across the capacitor, the average power used in the circuit, and the current through the circuit. So let's take it one after the other, starting with the reactance of the circuit. So reactance, says solution. The reactance of the capacitor is the first thing we are meant to calculate as the I. From our introduction to AC circuits, we were meant to know that the reactance of the capacitor is 1 over 2 pi Fc, where C is the capacitance of the capacitor. From what we have here, our C is 10 microfarad, which of course we know that micro is 10 raised to power minus 6. So that is 10 times 10 raised to power minus 6 farad. While the frequency from the circuit diagram is 25 Hz. So if we put these parameters together, the capacitance of the capacitor will be equal to 1 all over 2 pi times frequency, which is 25 Hz, times the capacitance, which is 10 times 10 raised to power minus 6. So if we simplify this following the law of indices, you know this can go up to become 10 raised to power 6. So that we have 2 times 25 is 50 times 10 is 500. So we have 10 raised to power 6 over 500 pi. And if 500 divides 1 million, that's 10 raised to power 6. We have 2000 over pi, of course in ohms. So our capacitive reactance is 2000 over pi in ohms, which in decimal form we're going to write it as 636. If you punch your calculator, 0.6198 ohms. That's what you're going to get in decimal form. Okay, that's about the first thing we are asked to calculate. We were also asked to determine the impedance of the circuit. From the circuit, as we can see, we have only the capacitive reactance and the resistance. The resistance is 100 ohms. The capacitive reactance is what we've gotten as 636.6198. So II, the impedance Z, since there is no inductive reactance, remember generally the impedance is XL minus XC squared plus R squared. But since XL does not exist, it means this is 0. And if it's 0, we'll have minus XC squared, which is the same as XC squared. So the impedance is going to be the square root of capacitive reactance squared plus resistance squared. Therefore, the impedance of the circuit is equal to the square root of, we got the capacitive reactance as 636.6198, and we square it. We were given the resistance as 100 ohms, so we square it as well. So that when you compute that by punching our calculator, you're going to have the square root of 415,284.735. You can confirm with your calculator. Therefore, Z is the square root of this number, which is going to give us 644.426 ohms, and that is the impedance. Okay, if we move ahead, the number 3 question we're asked to determine is the voltage across the capacitor. The current through the capacitor is the same with the current through the resistor. So VC is equal to I, then XC, capacitive reactance, according to Ohm's law. Okay, if we follow that, we therefore note that I was not given on the question and we've not gotten it. But we know that we know the impedance and we know the EMF. That the EMF of the cell is equal to the current through the circuit times the impedance, neglecting internal resistance. Remember? So it therefore means that the current is equal to EMF over the impedance. So we can actually use EMF over impedance to replace the current since we've not gotten the current. So VC, which is capacitive, the voltage across the capacitor, equal to E over Z times XC. Okay, and that is equal to, our EMF was given, as we can see in a circuit diagram, as 90 volts. So putting it here, we're going to have 90 all over, impedance was gotten as 644.426 times the capacitive reactance was gotten as our I number as 636.6198. So we're going to put it here, 636.6198. Okay, and when this is properly computed, the voltage across the capacitor will be 88.91 volts, and we've gotten that. So the next thing we were asked to determine is the average power used in the circuit. So the next thing we are asked to calculate is the power used. Power used, you know that power can be written in terms of current and resistance, that is R squared R. It can be in terms of current and voltage, that is IV, and it can be in terms of voltage and resistance, that is V squared over R. But since this is not a purely resistive circuit, it contains other resistance which is now referred to as impedance. So power used is equal to, and when you talk of power consumed, you are referring to this, but this is not going to be a resistance because that's not duly opposition in the circuit. So it is going to be I squared Z that we are going to use to determine that. And we also know that I was written in terms of E over Z since I has not been gotten. So this is going to be E over Z squared times Z. Of course, this is E squared over Z squared times Z. And this Z, we cancel one Z here. So the power used is E squared over Z. That's equal to, what is our E? We originally know that our E was given on the question as 90 volts. So have 90 squared all over, we got our Z as 644.426. So when you compute that, you have 8,100 over 644.426. And finally, the power used is going to be equal to 12.57 watts, as the case may be. Then finally, we're asked also to determine the current, and we have been writing the current in terms of the EMF over Z, which we can also get using the VC over XC because we already know the capacity, the voltage across the capacitor and the capacitive reactance. So the current is equal to EMF is 90, and the voltage, the impedance we solved to be 644.426. If you compute this, you get 0.14 ampere. Or you can decide to use the capacitance to get it, and the current is voltage across the capacitor all over the capacitive reactance, which is equal to 88.91 is the voltage across the capacitor, while the capacitive reactance is 636.6198. And when you compute it, you still get 0.14 ampere. See you next time.